Hello, welcome back students. In this lecture, we'll see metal oxide semiconductor field effect transistor, its basics and along with its biasing circuits also. So, what are the different types of MOSFETs that we are going to study? There are basically two types of the MOSFET. One is called depletion type of a MOSFET and second is called enhancement type MOSFET. Now, what is the exact difference between depletion type and enhancement type as far as MOSFETs are concerned? That we will see in the next diagram. Now, if you can see, closely observe the MOSFET characteristics. See, the basic thing that you need to remember if someone asks you that what is the difference between depletion type MOSFET and enhancement type MOSFET. So remember, in the depletion type MOSFET, channel is already present, and the electron flow happens, or electron flow goes through, these electrons go through this channel and being collected at the drain side. Okay, so the electrons emitted by the source will be collected at the drain side through this particular channel. So the basic difference between depletion type and enhancement type MOSFET is that channel is initially present in case of a depletion type MOSFET, and in case of enhancement type MOSFET, channel gets created, channels get produced, okay, or it get created. So like a FET, it is also having three terminal, namely drain, gate and source. Now if you can see, there is one P type of a substrate to which two N type of the semiconductor materials are etched, and these N type of a material constitutes one source, one is drain, and this P type substrate, to this P type substrate one metallic contact is taken and name it as gate. So this is gate terminal. Okay, now what is the difference? See, channel is already present, which is a N channel. The N channel is present between these two N type of the semiconductor region through which actually electron flow happens. Now the drain and source are connected to the N dope region. These N dope regions are connected via N channel. This is already clear. This N channel is connected to the gate via thin insulating layer of SiO2. Now this gate is connected to this P type substrate through one layer, and there is thin insulating layer named SiO2. So the name is metal oxide semiconductor, metal oxide. So this is metal oxide layer. SiO2 layer is the metal oxide layer which is present between the substrate and the gate, and the metallic contacts are made towards this SiO2 layer, and that's why the name is, this is SiO2 acts as a dielectric insulator, and also MOSFETs are also called insulated gate field effect transistor. If someone asks you what is the second name of MOSFET, it is IGFET, insulated gate field effect transistor, that we are going to see very soon. So SiO2 is a insulating layer which acts, or which serves the purpose, and which is present between the substrate and the gate. The N dope material lies on P dope substrate that may have an additional terminal connection called substrate. You can say this is optional one. In some of the cases, in some of the manufacturers will provide this substrate layer. Name of this substrate layer is SS, and P type substrate is already present. Now what happens about the working, that we will see in detail. Silicon dioxide. Silicon dioxide, it is an insulator referred to as dielectric. It sets up the opposing electric field within the dielectric when exposed to an external applied field. So it sets up a opposite electric field. So electric field will be set up when it is exposed to the externally applied field. External applying field, as you know the concept of biasing means applying the external voltages. So when external voltages are applied to this particular MOSFET, this SiO2 layer sets up an electric field which opposes the dielectric when exposed to the externally applied field. The fact SiO2 layer is an insulating layer means that there is no direct electrical connection. Listen to me carefully. There is no direct electrical connection between the gate terminal and the channel of MOSFET. If you can see, I will take you once again back to the previous diagram. There is no direct connection between channel and the gate. There is no direct electrical connection between channel and gate. Channel and gate are separated by this SiO2 layer, which is acting as a metal oxide layer. Okay. Then one more thing to remember, it is the insulating layer of SiO2 in the MOSFET construction accounts for very desirable high input impedance. As I told you in the previous lectures, that high input impedance is always preferred for the devices like FETs, transistors, MOSFET, so as the noise signals, which are very low voltage signals, should not drive the input terminals of the devices, and they should not get amplified. Therefore high input impedance is always preferable. So SiO2 serves two purposes. SiO2 serves two purposes. It avoids direct contact. It avoids the direct electrical connection between gate terminal and channel of the MOSFET, and also it gives the high input impedance. Now why MOSFET? If the FETs are readily available, why one should study, or why one should use MOSFET? So first of all, it consists of metal, it consists of oxide layer, and it consists of semiconductor. We will see one by one each layer. For the drain source and gate connection for the proper surface, in particular gate terminal and control offered by the surface area of the contact. See, if you can see, I will take you once again back to this next diagram. Here you can see these are metallic contact. This gate is a metallic contact, this drain is the metallic contact, this is a metallic contact. So it consists of metal. Now if it consists of metal, what else it consists of? It consists of oxide layer. Oxide layer is SiO2 layer. Okay, Si is semiconductor, silicon is a semiconductor. So the oxide layer is for the silicon dioxide insulating layer, and semiconductor for this structure, of which N type and P type regions are diffuse. MOSFETs are also called insulated gate FET or IGFET. It is also called IGFETs, as gate is insulated from the substrate. Okay, so MOSFET consists of three parts: metal, oxide, and semiconductor. So I hope this concept is clear, and we will proceed for the next one. Now you can see, if initially if VGS is 0 volt, that is gate to source is shorted and it is connected to ground, so there is no external applied voltage between gate to source, whereas drain to source are connected by the external battery VDD, and this substrate is also connected to the ground. Now what will happen? The electrons which are emitted by this negative terminal of the battery will enter the source region, and from this the electron will travel and will be reached to the drain region. Now you may ask, what is the function of gate then? If gate is grounded and electrons are direct flowing from source to drain, what is the purpose of this gate? That we will see in the forthcoming slides. But right now try to understand, as I told you in the FET, this is true in case of MOSFET also. Gate is acting as a controlling terminal. If VGS is equal to 0 and VDS is applied across drain to source terminal, this results attraction of free electrons from N-type lesion to the drain, and hence current will flow. This is the first case. When VGS is equal to 0 and proper value of VDS is applied, the current will start flowing. Okay, current will start flowing. This first concept is clear. Then what happens when now VGS is set to a negative voltage such as minus volt? What will happen? The negative potential at gate pressures the electron towards p-type substrate and attract the hole towards p-type substrate. This will reduce the number of electrons in the N channel available for the conduction. The more negative the VGS, the resulting level of the drain current ID is reduced. VGS is reduced to VP, pinch off, then ID is equal to 0. I will explain this thing in the previous diagram. If now in this case we apply a negative terminal, negative potential of the negative terminal of the battery to the gate and positive to the source, what will happen? Because of this negative terminal, the electrons which are earlier flowing, they will be repelled here towards the substrate layer. What will happen then? If electrons are not there, absence of the electron will be treated as holes. So holes are present. If holes are more in number, they will oppose the flow of electrons from source to the drain. The electrons which are earlier flowing from the source to the drain, they will be opposed by the presence of these holes, and these holes will reduce the ID. Now if we increase this VGS to some large value, the condition came that the channel consists of entirely holes, and further flow of electrons from this source to the drain is not possible, and hence drain current is 0, and we say that pinch off has occurred. Pinch off concept, which we have studied in the FET, it is equally applicable in case of a MOSFET. Try to understand. If I want to understand the pinch off, you need to apply negative battery voltage to the gate and positive battery voltage to the source. If gate to source junction is reverse bias, the electrons here are repelled towards substrate. As electrons are repelled towards substrate, the holes occupy their places. As holes occupy their places, the electrons which are earlier flowing from source to drain without any interruption will now reach to these holes, which will oppose this natural flow of electron, and we say that ID is reduced. ID, just assume for a timing that initially let's say ID is 5 milliampere, because if I apply the VGS, it can reduce to 4 milliampere, then 3 milliampere, then 2 milliampere, and a condition came when VGS, let's say VGS equal to 4 volt, that is minus 4 volt. If we apply at this condition, what will happen? the electron flow from source to drain completely stops, and we say that pinch off has occurred. Okay, so pinch off is a condition when gate to source junction is reverse bias and flow of electrons stops, and we say that MOSFET is operating under pinch off region. Is it okay? So this is the same thing which is explained. The theory points are mentioned here. You can see these electrons are repelled and holes occupy their places, and the flow of electron is disturbed, it is reduced, and because of that the current will be reduced. So this is how it happens in case of a depletion type of a MOSFET. Okay, in the depletion type of a MOSFET, I will just revise the thing. In the depletion type of a MOSFET, channel is already present. In the enhancement type MOSFET, channel get created or channel get diffused, but because the reverse bias voltage of the gate to source junction, it can control the flow of electrons from source to drain, thereby reducing the value of ID. Okay, so we'll stop for this particular lecture. We will continue with the same concept where we are left, and in the next lecture we'll see the characteristics of VGS versus ID and VDS versus ID also. So till then, thank you very much and keep learning.